using the law of cosines. If we have a triangle where we know angle, angle, side, in this case angle A, angle B, and side little a opposite angle A, or if we have side, side, angle, in this case side little a, side little b, and angle A, we can find the remaining sides and angles of a triangle. And this is the law of sines. It's the sine of angle A divided by the side length of A equals the sine of angle B divided by the side length B equals the sine of angle C divided by the side length C. And there's also the reciprocal version of the law of sines. We can use either version, but each version makes solving one type of equation easier. But what if we have side angle side, in this case side little b, angle A, and side little c? Or what if we have side, 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 in this case side A, side B, and side C without any known angle? In these two cases, side angle side and side, 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 the law of sines will not work, or at least not to start solving a triangle. Fortunately, we have the law of cosines that works for side angle side and for side, side, side. The law of cosines is the formula a squared equals b squared plus c squared minus 2bc cosine A. The lowercase a, b, and c are the side lengths a, b, and c. And cosine A, as in cosine capital A, is the cosine of angle A, which is opposite side little a. And there are two other versions of the law of cosines. The second one is b squared equals a squared plus c squared minus 2ac cosine B. And there's the final version, c squared equals a squared plus b squared minus 2ab cosine C. The law of cosines, to me, is the Pythagorean theorem with an adjustment for an angle other than 90 degrees. Here's the first problem we'll look at. We have angle B measuring 131 degrees and side little a and side little c measuring 13 and 8 units respectively on either side of angle B. We have a side angle side situation which requires the use of the law of cosines. And what are we trying to find? We're trying to find what's missing, angle A, side little b, and angle C. We label sides little a and little c. Side little a is 13 and side little c is 8 units in length. And since we have angle B, we will start to solve for little b by using this version of the law of cosines, and that's b squared equals a squared plus c squared minus 2ac cosine B. To use the equation to solve for side little b, we replace the little a in the formula with side a, which is 13. We replace the little c with the length of side c, which is 8 units. Now for cosine b, we substitute the cosine of 131 degrees for the cosine b in the formula. And here's the formula with everything filled in. We have b squared is equal to 13 squared plus 8 squared minus 2 times 13 times 8 times the cosine of 131 degrees. In this lesson I'm using the TI-Nspire CX graphing calculator pictured here. Since we're using degrees because of cosine 131 degrees, first go to the Home button at the upper right corner of the keypad, go to option 5, Settings, which is highlighted here in blue, press Enter, press 2 for Settings, press 1 for option number 1, General, and we see that we're in degrees for angles, which is where we need to be. If not in degrees, we change the setting to degrees and tab down to OK to make the change. Next, we press Escape at the upper left of the keypad. Then we go to the calculator page icon at the lower left of the view screen, here circled in red. Press Enter. Then we enter the right side of the equation as shown above, 13 squared plus 8 squared minus 2 times 13 times 8 times cosine 131 degrees. We get the cosine option by pressing the trig button circled in red on the keypad. Press Enter. We get 369.46 for side B. But we have to be aware enough to know that it's not really side length B, but instead b squared, so we take the square root by placing the square root sign, then the answer key by pressing Control, then the negative sign key. This places the last answer calculated inside the square root bracket or inside the radical. Press Enter. We see a couple things here. We see the 369.45 out to 11 decimal places, which shows the very accurate storage of the number for b squared, which results in a very accurate answer. and we see our answer given of 19.2213 units for side length B. And we'll call it 19.2213 on our drawing, but the calculator storage takes it out much further. Next, we need to use the law of sines to find either angle A or C, and here's the formula for the law of sines. Sine A over side length A equals sine B over side length B equals sine C over side length C. We set up the equation to solve for sine A by using the equation sine A over side length A equals sine B over side length B, and that will be sine A over 13 equals sine of 131 degrees over 19.2213. To solve this equation for sine A, we cross multiply the 13 to the other side of the equation, and that leaves us with sine A equals 13 times the sine of 131 degrees divided by 19.2213. And here it is entered in the calculator. Note that in place of the 19.2213 is ANS. The ANS is the last thing calculated, and it is the more exact stored answer for the length of little b, which will give us a more accurate answer than the 19.2213 that we wrote on the triangle drawing for length b. Press enter. Look at the stored number for 19.2213 taken out to 11 decimal places. Next, we solve for angle A by taking the arc sine or inverse sine of 0.510434. And here it is entered in the calculator, again using ANS to get the value for sine of the angle to get our answer as accurate as possible. Press enter. We again see the sine of A carried out in storage to 11 decimal places, helping the accuracy of our answer. Next, we write in that angle A is approximately 30.69 degrees, which is rounded to the nearest hundredth place. Now the last thing we need is angle C, and to get angle C we have a choice. We can subtract 131 and 30.69 from 180 and write in our answer as 18.31 degrees shown in the calculation. But to check our answer of 18.31 degrees, we'll use the law of sines one last time, and in this version it's sine C over 8 equals sine A, which is sine 30.69 degrees over 13. And cross-multiplying the 8 and entering it into the calculator, this is what it looks like. Note that we used 30.6927 for the angle of 30.69 degrees to get a more accurate answer. Press enter. We get to the sine of angle C is 0.314113. We solve for angle C by taking the inverse sine of 0.314113 as entered here in the calculator, again using ANS for that sine value. Press enter. We get 18.3073 degrees. And rounded to the nearest 100th of a degree, that's 18.31 degrees, just as we calculated a little earlier by subtracting from 180 degrees, which confirms our earlier calculated answer, which we write in the far left corner of the triangle. I hope the process of solving first for the unknown side B using the law of cosines, then solving the unknown angles A and C using the law of sines was very clear to you. If not, I invite you to rewind and use the same process on other similar problems. Here's another problem. Again, it's a side angle side application with side A equal to 14 units in length, angle C equal to 42 degrees, and side B equal to 12 units in length. At this point, I invite the viewer to stop the video, then solve the triangle's unknown sides and angles, then restart the video to see if you got it right. Labeling. Side A is 14 and side B is 12. Since we need to first find side C, we use the version c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. Here's what we'll be entering with the numbers. C squared equals 14 squared plus 12 squared minus 2 times 14 times 12 times the cosine of 42 degrees. And here it is entered and calculated in the calculator. We have to remember that this number is side C squared. And to find C, we take the square root of this number, so side C is about 9.50281 units in length. And here's side C labeled in the triangle. Now here's a setup using the law of sines to find the sine of angle A. It's the sine of A over 14 equals the sine of 42 degrees over 9.50281. And cross multiplying, we have the sine of A equals 14 times the sine of 42 degrees divided by 9.50281. And here it is entered and calculated in the calculator. We get sine A equal to 0.985796. From here we find angle A by taking the inverse sine of 0.985796. And in our calculator, here it is worked out. So angle A is calculated to be 80.3318 degrees. So we label angle A as 80.33 degrees. Now we'll solve for sine C by setting up the equation sine B over 12 equals sine 42 degrees over 9.50281. And solving for sine B, we have sine B equals 12 times the sine of 42 degrees over 9.50281. And here is sine B entered into the calculator. We get sine B is equal to 0.844968. So angle B is the inverse sine of 0.844968. And using the calculator, angle B is 57.6685 degrees. And rounded to the nearest hundredth of a degree, angle B equals 57.67 degrees, which is labeled inside the triangle at angle B. And as a final check, we add all three angles together and get 180 degrees even, which demonstrates that our answers are correct, so everything checks out. Are these the answers you got when you worked it out ahead of the video? I hope so, and if not, I hope you were able to figure out where you went wrong. Now let's look at this problem. We have this triangle, and we are asked to solve having three side lengths. Side A is 27, side B is 19, and side C is 24 units in length. This is a different situation than the first two problems in this lesson. Instead of being a side angle side situation, we have a side application. Definitely not a law of sines application, at least not at first. This is again a law of cosines application. The first thing to do is to figure out what to do first, which angle to solve for first. I have found by experience that the angle to solve for first using the law of cosines is the largest angle, and I'll explain later why this is the case. In this triangle, the largest angle appears to be angle A, so that's the one we'll solve first, and we can tell that because angle A is opposite the largest side, which is 27. And since we're going to solve for angle A first, we need to have the A version of the law of cosines, and that's the one what we have to use. So we use this one. Next, we replace A, B, and C in the formula with the side lengths of 27 for A, 19 for B, and 24 for C. Next, we can do some consolidating calculations using the calculator. Those calculations are 27 squared equals 729, 19 squared plus 24 squared equals 937, and 2 times 19 times 24 equals 912. And here the calculations are inserted into our equation. Next we go about solving by first subtracting 937 from both sides of the equation. 937 minus 937 cancel to equal 0 on the right side of the equation. We bring down what's left. Negative 208 equals negative 912 cosine A. Next we divide both sides of the equation by negative 912. Negative 912 divided by negative 912 cancel to equal 1 on the right side of the equation. We make the calculation and bring down what's left, and it's cosine A equals the fraction 13/57. And solving for A, angle A equals the inverse cosine of 13/57. And going to the calculator, angle A is 76.8165 degrees. And we label the angle accordingly, and rounding to the nearest hundredth, we have angle A measures 76.82 degrees. Next, using the law of sines, we'll solve for angle B by first setting up the equation sine B over 19 equals sine of 76.8165 over 27. And cross multiplying the 19, we have the sine of angle B equals 19 times the sine of 76.8165 degrees divided by 27. So angle B is the inverse of the sine of all that on the right side of the equation. And here it is entered in the calculator. Note that for the angle I used A and S, which is the last number stored in memory, to get as accurate a number as possible. Press enter, we get angle B equal to 43.248 degrees. And then we write in our answer inside a triangle, which is 43.25 degrees rounded to the nearest hundredth place. And now we set up to solve for angle C by taking sine C over 24 equals the sine of 43.25 degrees over 19. And cross multiplying, we have sine C equals 24 times the sine of 43.248 degrees over 19. And angle C is the inverse sine of all that. And here is the expression for angle C entered in the calculator. Note again I'm using ANS for angle B since it's a more exact number stored in memory. Press enter. We get an angle for C of 59.9355 degrees. So we write in the triangle that angle C is 59.94 degrees, which is rounded to the nearest hundredth place. Now we check by adding up the three angles of 76.82, 43.25, and 59.94 degrees. They add up to 180.01 degrees, and rounding to hundredths, this is the way it worked out. Not too bad. Here's the last problem we'll be looking at in this lesson. This is another side-side-side application. Side A is 28 units in length, side B 35 units, and side C 17 units in length. One of my students, Justice, worked this problem out by first using the law of cosines and then proceeding to the law of sines. Her angles did not add to 180 degrees, and she wondered how that could happen. She had me look over her calculations, and they all looked good. The calculator was in degrees. I didn't know initially what went wrong. I later figured out that, and part of my reason for creating this lesson was to explain how it happened. I invite the viewer to stop the video and try to work out the problem, then play ahead to see if you got the problem right. I strongly suggest using the law of cosines to calculate the largest angle first. We're going to start this problem by using the law of cosines to solve for this largest angle, B. But to do that, we'll need the B version of the law of cosines, which is B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. Now we label the sides A, B, and C. Here's the formula with all the sides entered. We have 35 squared equals 28 squared plus 17 squared minus 2 times 28 times 17 times the cosine of angle B. And here are the initial calculations in the calculator. So we have 1,225 equals 1,073 minus 952 times cosine B. Next we subtract 1,073 from both sides of the equation. 1,073 minus 1,073 cancel to equal 0 on the right side of the equation. We bring down what's left, and it's 152 equals negative 952 times the cosine of angle B. Next we divide both sides of the equation by negative 952. Negative 952 divided by negative 952 cancel to equal 1 on the right side of the equation. We have cosine B equals negative 0.152 divided by 952. So angle B equals the inverse cosine of negative 152 over 952. And using the calculator, angle B is 99.19 degrees rounded to the nearest hundredth place. And so we label the angle on the diagram. Now I'll answer Justice's question about her angles not working out. She worked this angle out using the law of sines. This sine of angle B is about 0.987. Now let's try to recreate angle B by taking the inverse sine of 0.987. We get about 80.813 degrees and not the 99.187 degrees we started with. This angle, 80.813 degrees, is the one that Justice calculated. And why is that? It's because the inverse sine from 0 to 180 degrees is not a function because it has two possible outputs for the same input value. And why is that? Because on a unit circle, like the one shown here, for every value of sine in the first quadrant between 0 and 90 degrees, there is an equal value for sine somewhere in the second quadrant. For instance, the sine of a 30-degree angle in one half, that same is the same as the sine of 150-degree angle on the other side. Therefore, to get the correct angle using the law of sines, we have to know not only the value of the sine of the angle, we must also know if the angle has its terminal side in quadrant 1 or in quadrant 2. From here, I'll just wrap it up quickly. The sine of angle A over 28 equals the sine of angle B, or the sine of 99.1894 degrees over 35. So the sine of angle A equals 28 times the sine of 99.1894 degrees over 35. So angle A is the inverse sine of all that. And here, entered in the calculator, the angle A is about 52.16 degrees. And we label angle A as 52.16 degrees rounded to the nearest hundredth place. And finally, to work on angle C, we have the sine of angle C over 17 equals the sine of angle B, or the sine of 52.16 degrees over 28. And cross-multiplying by 17, we have the sine of angle C equals 17 times the sine of 52.16 degrees divided by 28. So angle C equals the inverse sine of all that. Note that I have A and S for angle A because that was the last thing calculated and it's highly accurate in the calculator's memory. Press enter. We get about 28.65 degrees. And we label angle C in the triangle as 28.65 degrees rounded to the nearest hundredth place. And adding these three angles together, we get a total of 180 degrees, verifying that our answers are correct. One key to using the law of cosines and not having the trouble Justice, I, and others have had in using the law of cosines is to use the law of cosines first for the largest angle as the first angle calculated. The inverse cosine is a function for all angles between 0 and 180 degrees. I just wanted to wrap up with a few items for emphasis at the end of this lesson. In addition to these three versions of the law of cosines shown here, there are these three versions that can be used to solve a side-side-side situation. These equations are the same ones as above, but solved for the cosine of the angle. And as a hint for working problems, if you have a side-side-side application, I recommend using the largest angle first, especially if it's an obtuse angle. In the case of the triangle showed here, it would be angle B. Why is that? It's because if you try to find an angle larger than 90 degrees with the law of sines, there will be two possible solutions when you take the inverse sine as a ratio. For law of cosines, there will be only one possible solution, even for an obtuse angle. So after using the law of cosines on the first largest angle, you can use the law of sines on either or both the remaining angles with better confidence. And finally, go out to as many decimal places as possible when calculating answers and leave in the calculator's memory an intermediate solution whenever possible. This technique will improve your accuracy. This has been Using the Law of Cosines. Thanks for viewing.